Separation of substances. Your cell phone is mainly made of plastics and metals. Isn't it interesting to know that those elements are made to add up to something so useful and entertaining? But how did we get our raw ingredients from nature? The answer is a group of clever hacks known as separation techniques. Simple separation techniques apply to many physical scenarios like separating cream from milk, extracting water from soil, or even sifting out small and big particles of gold from river sand. But not all mixtures are so easy to separate. In some of those cases, we can exploit the differences between physical properties within a mixture, like particle size, density, or boiling point, to extract what's required. For example, petroleum, which are valuable as fuels and make good raw materials for generating electric power, to separate them, scientists rely on one important feature. Petroleum components boil at different temperatures. During the boiling process, each component vaporizes at a precise temperature, then gets separated into a container and is collected as a liquid as it cools. Separation techniques also take us to the sea. In some drought countries, the ocean is the only available water source, but humans cannot drink salt water. One way to get around this problem is to remove salt from seawater with reverse osmosis, a process that separates water's ingredients by size. A membrane with pores bigger than water particles but smaller than the salt particles only lets fresh water pass through, transforming what was once undrinkable water into drinkable water. Meanwhile, in the medical world, blood tests are a vital tool for evaluating a person's health. But doctors typically can't examine blood samples until they have separated the solid blood cells, which is dissolved in lipid plasma. To do that, a powerful rotational force is exerted on the test tube, causing heavier substances with higher density, like blood cells, to move down the test tube. Meanwhile, lighter substances with lower density, like plasma, move to the center of the test tube. The test tube's contents divide clearly, and the blood cells and liquid plasma can be separated and then tested independently. But sometimes, unlike oil, seawater, and blood, the parts of mixtures that we want to separate share the same physical properties. In these cases, the only way to separate or isolate the ingredients is by chemical reactions, which is a complex process relying on interaction of mixture and other substance added to separate the mixture. One of these methods is chromatography, a tool forensic scientists use to examine crime scenes. They dissolve gathered evidence in a gas and can monitor and analyze the ingredients as they separate and move at various speeds due to their unique chemical nature. That information then tells scientists precisely what was present at that scene, often helping to identify the culprit.